Welcome students. In the era of nuclear energy, now we are begin the topic nuclear fusion and nuclear fission. This topic is really important for the CBSE NEET as well as for the IIT for class 12 physics. The chapter name is a nuclei. So let's begin with the first topic, which is a nuclear energy. So nuclear energy is divided by two subsequently topic, that is a nuclear fission and nuclear fusion. When a heavy nucleus decays into two or more intermediate masses of a fragment, it is called as a fission. For example, if I just take a nucleus. So as you know students, when the in the nucleus, what is the present over there? Number of neutron and proton. So when the number of neutron and number of the proton is start to increase, the particle or the nucleus becomes unstable. So what will be happen if I'll just give some amount of energy so that nucleus breaks into two or more than two subsequent particles, and this is called as a nuclear fission. Simply, a heavy nucleus divided into two small nucleus is called as a nuclear fission. The fission of two nuclei. When light nuclei fuse into heavy nucleus is called as nuclear fusion. Means if we are taking two nuclei and that will be fused and together they make a heavy nuclei, that is called as a fusion. So firstly we will take the topic nuclear fission. The phenomena of splitting of a heavy nucleus into smaller nuclei with liberation of energy is called as a nuclear fission. Radioactive decay can be induced by collision between two nuclei or by the collision of a neutron with the nucleus. Students, I hope you getting the meaning of radioactive decay. So if the nucleus means number of proton and number of neutron start to increase, that particle, as I told you, becomes unstable. So they start to decay some radiation like alpha ray, beta ray, and a gamma ray. These are some radiation or a rays when the nucleus is actually unstable. So when the nucleus is unstable, they start to decay in the form of alpha, beta, gamma particles, which is called as a radioactive decay. Understood, students? So all these things are happen because of the stability. Everyone wants stability in our life. Similarly, nucleus also. So like this is a neutron. Neutron has chargeless, but yes, they have some mass. Okay, so because of that mass, it has some momentum. Because of that, it has some energy. Okay, but they don't have any charge. Okay, so they have some energy. Because of this energy, if that will be applied on the target nucleus, so this will be fused into two nuclei. Okay, and there will be neutron, which we call as the energy radiates. Okay, so these are the energies and these are the two nuclei. So this is called as a nuclear fission, where a larger or a heavy nuclei breaks into two lighter nuclei. I hope you understand, students. So the fission process was first observed by Othel and Stresemann. Othel and Stresemann. So his theory was successfully explained by Bohr and Wheeler using liquid drop model. Students, liquid drop model you were really studying in the higher secondary classes. So you just take the thing like by this example they explain this phenomena as like if I'm just taking a heavy water droplets and give some energy, the water droplets becomes breaks into their fragments. Clear? Like this they explain by the help of water. Okay, they explain this kind of a things. So when uranium 235 collide with a neutron, the main product of a two nuclei, both the size, roughly half the size of the original parent nucleus, like this. So what we have taken one neutron, one a very heavy nucleus particle, which is called as uranium, which is an unstable in nature. Unstable in nature it is actually. Because after this energy, this nucleus of a uranium 235 breaks in the Ba krypton plus three nucleons, or here the three nucleons are, there is a no proton for that, there is a only neutron. So three neutrons we can say, and plus large amount of energy, which is a 200 mega electron volt energy. So this is actually the process. Unstable heavy nucleus or a heavy nuclei break into the lighter nuclei. Okay, these both are lighter nuclei. Okay, move ahead with this topic. The projectile used to boundary a heavy nucleus need not to be proton. It can be proton 6.9 mega electron volt or neutron 8 mega electron volt or alpha particle. So as you can see students, for a like breaking the nucleus, a heavy nucleus we can say, there is a no need of only neutron. Okay, as in this experiment we taken actually the neutron, but it not only the neutron only. We can take this experiment by the deuteron also, by the alpha particles also. Okay, the particle actually which is a lighter in nature, and electron we can't, because some particle electron is actually we can't send in the nucleus, so we can just take the proton and neutrons. Okay, so we can take like a deuteron with have a deuteron actually we are deuteron which we are taking, that we are just taking the neutron and a proton particle in that emerges. So alpha particle we can take, deuteron we can take, and proton as well. The fission product fall into two groups, one of the atomic number in the range of 35 to 42 and atomic mass in the range of 80 to 110. Other of the atomic number in the range of 51 to 57 and atomic mass in the range 125 to 160. Some of the energy released in the form of a gamma rays like heat energy, sound energy, light energy, like this. So we have a atomic mass range that 80 to 110. As I told you, atomic number range 51 to 57, and the atomic mass range 125 to 160. Like these, in these particular range, actually the fusion takes place. Like when the heavy nuclei breaks into the lighter, so the range of these that lighter nuclei will be this. 0.6% of a mass of a reactant is converted into the energy. So neutrons release the fission are two types, like prompt neutrons, which are released in the time period of 10 to the power 40 minus 14 second. These are called as prompt neutrons and constitute 99.36, not suitable for the chain reaction and high energetic. Next one, we have a delayed neutrons, which are released after 10 to the power minus 14 second. So this is released at the time period 10 to the power minus 14, and this is also released after 10 to the power minus 14. This is exact, this is a later than that. This is called as delayed because it will be take few seconds more time, okay, for rather than this. So which we are called as delayed neutrons, which are emitted by unstable fission fragments. So constitute 0.64. They are called the chain reaction. Chain reaction is a process by which one, as I told you, heavy nucleus actually breaks into the fragments, into the lighter nuclei, and that lighter nuclei actually again breaks into their two lighter nuclei like this. This is a heavy nucleus. After breakage, this will be converted into the lighter nuclei with the energy, and these lighter nuclei again breaks into the two more lighter nuclei like this, and this lighter nuclei again breaks into lighter nuclei. So a huge explosion occur, as you can see. Okay, huge explosion occur, lighter nuclei in this case, and these again. So this process is a continuous process, not stopping. So it will be take infinite time to actually stop. This is called as chain reaction, which is a dangerous actually in the field of energy and in the field of any atomic bomb and the nucleus around. Next we have less energetic will play an important role for the running nuclear reactor, or average 2.5 neutrons are produced in each fission. Event masses defect are rarely equals to 0.214 AMU. In the case of energy consideration, that will be fast neutron have must energy 2 mega electron volt. Slow living neutrons must have energy 0.025 electron volt. Total energy which is released actually 200 mega electrons volt. The main feature, if I am talking for the nuclear reactants or nuclear reaction, there can be many different possible reactions product. The reaction produces more free neutrons than it is uses. These free neutrons can then induce fission in the other nearby uranium nuclei, creating a chain reaction. The reaction releases energy. The extra binding energy is released in the form of gamma rays and through the kinetic energies of the particle produced. Energy from the fission. So the binding energy per nucleon of the 92 uranium 235 is about 7.6 mega electron volt. For many of the products, the binding energy is about 8.5 mega electron volt, and the difference is a 0.9 mega electron volt. Since there are 235 nucleons, the energy per nucleon is about 210 mega electrons volt, and for 1 gram of a pure uranium, this would be correspond to total energy of about 9 to the power 10 joule. For a comparison of a 1 gram of a TNT release about 4200 joule. So student, if we are taking just value of a comparison, like the previous one to the first one, like this is a parent nuclei or to the relative daughter nuclei, so that the energy which is approximately released in the joule, that is a 4200. Next we have some questions. When the lighter nuclei fuse into two heavier nucleus, it is called as a fusion, fission, chain reaction, or none of these. The correct answer for this question is a fusion. Next question we have, when the heavy nucleus decays into the two or a more intermediate mass fragment is called fusion, fission, chain reaction, both A and C. The correct answer is fission. Now the next topic is a chain reaction. What is the meaning of a chain reaction? Here we will see in the detail. Next topic is a chain reaction. So let's start the chain reaction topic. A self-sustained nuclear fission reaction without the supply of a neutrons from any external source is called as chain reaction. Means if we are just taking a nuclear fission reaction, so without supplying the neutrons, like we have just taken one times of a neutron for a one time of a parent, one type of parent. Actually, parent nuclei is divided into subsequent daughter nuclei. So the daughter nuclei do not need any energy for further breakage. So they have a self actually sustained nuclear process with the first sources. That's why we are saying self-sustained nuclear fission reaction without the supply of a neutrons from any external source is called as a chain reaction. Regarding chain reaction, it can be initiated if there is any availability of a one slow thermal neutrons. By using moderator, fast neutrons can be slowed down to sustain chain reaction. And it is characterized by multiplication by factor K, where K is equals to number of neutrons at any generation and number of neutrons in any preceding generation. So if K is equals to K is less than 1, the reaction is undercritical. K is equals to 1, the reaction is critical and energy produced in a steady rate. But if K is equals to greater than 1, it is the supercritical and that is the explosive. So this is a more dangerous situation which in the era of like fission process. The principle of a chain reaction gives by E. Fermi. An explosive chain reaction is a working principle of atomic bomb which is designed by Oppenheimer. Oppenheimer actually first designed the atomic bomb. So controlled chain reaction is a working principle in the nuclear reactor. The first reactor is designed by Fermi. So the principle is actually given E Fermi, which in which principle the work actually did by the Oppenheimer, and the chain reaction working principle and the first reactor was designing actually did, that is a Fermi. So that explosive chain reaction, which is by which atomic bomb is created, that is the Oppenheimer. And the next one is a nuclear, which is a controlled chain reaction. We can do control. This is a Fermi. Explosion are of two types. That is an atomic bomb, which is a actually not controllable, but controlled chain reaction is in the era of a nuclei. That is a very fantastic research which is designed by Fermi. Example of a chain reaction like uranium-235 breaks into the Ba-142 and krypton Kr-92 with the energy that uranium-235 again breaks, and here as you can see uranium-235 again breaks. So there will be huge amount of energy released. Factor which is influencing the reaction, natural uranium is a more than natural uranium-230 92-238, which doesn't radially undergoes the fission of a U-239. Natural uranium is enriched to increase the concentration of a 92 uranium-235. It's a difficult engineering process, and the piece of a uranium is small. Many of the nuclei are close enough to the surface of a released neutrons, which escape before inducing another fission event. The critical mass is a minimum about amount of the nuclear fuel material needed to sustain chain reaction. So critical mass means a particular body which have sufficient mass. This is actually need for this device. Now moves on the MCQ part. A self-nuclear reaction without the supply of neutrons from any external source is called as a fission, fusion, chain reaction. None of these. The correct answer for this is chain reaction. The dash is the minimum amount of a nuclear fuel material needed to the chain reaction. Mass, critical mass, mass number or atomic mass. The answer is a critical mass. Now we are moving with the nuclear power plant. Students, this is not in our syllabus for the CBSE, but this topic is really important for the NEET and IIT JEE purpose. So I'll just take in the topic with a little bit brief, not like core purpose. Now we start with the first topic, which is a nuclear power plant. Nuclear fission is used to control the way of a nuclear power plant. Safety is always a major concern at the nuclear fission reactor. All reactors are designed with extensive safety features. The largest design include passive safety feature that do not require manual operation or electronic feedback to deal with the energetic situation. Component of the power plant. Fuel contains uranium-235-92 that can be added or removable from the core of while nuclear reactor operating. Control rod contains material that absorb the neutrons. They can insert it or removed from the core of control the number of free neutrons and adjust the fission rate. Moderators are used to slow down the fasting neutron, for example, heavy water, graphite, etc. It can also carry some heat to separate the engine, whereas generator convert the electrical energy. This heat engine operates according to the law of thermodynamics. Now move with the solution question part. Dash process is used to the nuclear reactor. Fusion, breeding, fission, acceleration. The correct answer is a fission. Fuel rod contains that can be added or removed from the core while the reactor is operating. These are the options. The correct answer for this question in 92 uranium 235. Nuclear reactor. Nuclear reactor are three types: research reactor, breeder reactor, or power reactor. Research reactor. They produce neutrons as a radioisotope needed for the research purpose, like APSARA, SIRs, US, Zerilia, which we are saying as a ZERLIA, Purnima, and Bark in India. So Apsara, Cyrus, Zeleria, and Purnima at Bark in India. Breeder reactor. The breeder reactor convert non-fissionable material, like which we use uranium-235 in the fissionable material like plutonium-239 and generate electrical power. These are the reaction of these. Power reactor. These are used for generation of electric power. For example, Tarapur, Kolampur, Kota, Norar, Kararpur, Karaiga nuclear power plant in India. The power output of a nuclear reactor is given by P is equals to NE by T, where N is equals to number of a fission taking place in the time of a T, where energy is energy released per fission. So this is a important formula for NEET J aspect. An exgram of a nuclear fuel of a mass A undergoes the fission of a time T and energy E released per fission. Then power output in the nuclear reactor is given by NAX next by R. Bark has 4 research reactors in India. Apsara, which actually established at the 4 August 1956. Cyrus, Canada, India reactor for US. Cherlia, zero energy reactor for lattice investigation and new assemblyization. Purnima, plutonium reactor for neutronic investigation, multiplying assembles. Nuclear reactor. So it is a device which control chain reaction takes place releasing large amount of heat energy. It also convert heat energy into electrical energy. Principle. Nuclear reactor works on the principle of a nuclear chain reaction. The chain reaction is made possible by slowing down the fission neutrons by moderator. As you can see this. So nuclear reactor. The thermal neutrons produces further fission for uranium-235. The essential feature of a nuclear reactor are a fuel moderator, controlling rod, radiation, shielding and reflector, and coolant. Fuel. Nuclear fission takes place in the core of a reactor. It contains enriched uranium as a fuel in suitable fabricated form. Enriched uranium contains 90% of uranium-235. The fuel rods are tightly sealed in the aluminum cylinders in the border reactor. Non-fissionable uranium-235 is converting into fissionable material and produces more consumed. Moderator. The core contains moderator used to slow down and fast down the moving neutrons. Heavy water or graphite are used to the moderator. Control rods. The change reaction inside the reactor can be controlled by inserting the controlling rod into the nuclear reactor. Boron and cadmium rod are used to controlling rod which have a high absorption of a neutron. Coolant and large amount of heat is developed in the reactor due to chain reaction. This heat is removed by using suitable like a modern sodium etc. Radiation shielding and reflector. The core of is surrounded by reflector and reflect escaped neutrons which do not participate in nuclear process. To protect harmful radiation, thick walls of cement, concrete, steel load provided around the reactor. The heat generated is used to heating water, producing steam. The steam rotates turbine generate electricity. Now let's move on to some question part. The control rod in the nuclear reactor are made up of boron and cadmium. The chain reaction is made possibly by slowing down the fission neutron using moderator. So I hope you understand this much topic, students. This is all much about for today's class. Next topic is our nuclear fusion. So let's tomorrow in the next time we will see that topic. Till that, take care everyone.